Welcome to lesson 3.11. We're going to continue writing and solving rational equations in real-world contexts. Before we get started, important to remember that you have your real-world relationships and equations that we discussed handy and ready, and that you're following the protocol that we have for successfully solving these equations. A couple of things to note here are that when we have multiple things working together or doing something together, or you are taking multiple trips, you can use these relationships between, for example, the time it takes you to go one place plus the time it takes you to go another place will equal the total time. Same with work here. You can use those to relate different things being done all together. Also, make sure that you're taking your time finding the variable that you're going to solve for, representing it the way that you want to represent it, and going through each piece of information that you know and recognizing whether it's a rate, a time, a distance traveled, and draw a picture if necessary. That can be very helpful. I'm looking to make sure that you have each piece represented in your solution, so it might be a good idea to go ahead and just make sure that you're labeling your understanding step, your planning step, your solving step, and the step that you are checking, particularly to make sure that your units are correct. All right, let's go ahead and tackle this one. So write it down, go ahead and follow through with your protocol, understand, plan, solve, and check. Your goal is to treat this as if it is a test question, so you should not at any point give up or stop. I'm not going to go through with the whole solution. I may give a couple tips here or there so that in case you try it and you find that you may have messed up at a crucial point, you can then fix it and continue solving. All right, hopefully that went well. Because this is a rather challenging problem, what I'm going to do is I'm going to give you the equation that I wrote to solve this problem, and I'm not going to tell you where some of the pieces come from. What I want you to do is look back at the problem and see if you can then, if you weren't able to come up with this equation, if you can figure out where each piece comes from. So I used the relationship that the time one way plus the time going back will equal the total time traveled. And that allowed me to write the following equation. And since I saw that this was a rational equation, I actually rewrote this side as 12 over 5. All right, so hopefully this helps. Go ahead and spend a little time, if you weren't able to come up with this equation, reworking through your understanding step to make sure that you get it, and then go ahead and solve and check your work. Once you've done so, go ahead and press play, and we'll move on to one more. All right, so here we have a situation where there's a study done to measure the average number of minutes per day that Americans watch TV between 1950 and 2000. And the study came up with an equation which would model that average amount of time spent watching TV in terms of the number of years X since 1950. So go ahead and answer both questions A and B. Make sure to make a nice, neat table for part A. And then as an extension question, what I want you to do is notice that this equation is said to model for the years between 1950 and 2000. And I want you to think about whether you'd like to use this equation, think it makes sense to use this equation for years after 2000. So the way that you can test that is to try some x values that would move you past 2000 and go quite a bit into the future and see what you notice to happen as you increase those x values. And then think about our your society right now and whether you think that would make sense. And we'll go ahead and have a discussion on that when we meet again.